Good morning, Year 6. So, for your lesson today, it's another lesson of reviewing previous learning, things that we've done previously in school. And we spent a good few weeks looking at fractions. I think it was about 6-7 weeks we looked at fractions in total. We looked at fractions for so long because it's really important for you to have a good understanding of fractions, not just for your maths education in school, but also for future life, because they pop up absolutely everywhere. And so what we're looking at today is looking at adding and subtracting fractions, something that you would have first done in year 3, would have been built upon in year 4, 5, and we did quite a lot of work within it in year 6 as well. So that's what we're looking at today, adding and subtracting fractions. Now, hopefully you've remembered that a really, really important thing with when you're adding and subtracting fractions is that the denominators need to be the same. Okay, just a reminder what the denominator is. If we had 2 7s, for example, this 7 here is the denominator. The denominator is the bottom number, and it's how many times the whole has been split equally into how many equal parts the whole has been split up into. So the denominator, whether you're adding or you're subtracting fractions, they need to be the same. Okay. Now the reason for that is, okay, just as a recap here, if you had this question, 1/3 add 1/5, and I've drawn them both in bar models here. This is representing a third. It's been split up into 3, and this is one of them. This has been split up into 5, and this is one of them. So you can see we've got a third and a fifth, and the question is 1/3 add 1/5. Now, if we were to just begin to add these now without converting the denominators, what if we were to add? Well, there's 2 there, and then what do we do? Do we also add these 2 to 2 8s? That would be incorrect, because neither of these are split into 8. So that answer is completely incorrect, because this hasn't been split up into 8, and I remember a fraction is how many parts this has been split up into, and this one hasn't been split up into 8, so it's doubly wrong, if you like. So the way to do this is to make those denominators the same. Remember, this is just recapping old learning, is to make sure that those denominators are the same, and making both these fractions the same size, making them equivalent fractions. Now, there's a way that you can always find a denominator that is in both of these times tables, because that's the key to it. What number is in the 3 times tables and what number is in the 5 times tables? Now remember, there is always a way to find one, and you can do that by multiplying the denominators together. Sometimes it will get you to the lowest common denominator, sometimes it won't, but it will always find you a denominator that is in both of the times tables. So a number that is in the 3 times tables and the 5 times tables. Because remember, we're trying to just still make these equivalent fractions. The fractions are the same size, but when the denominators are the same, then we can begin to add them to see the answer to the calculation. So if we were to multiply 3 and 5 here, we all know that it is 15. So both the denominators are now going to be 15. And in this case, it actually is the lowest denominator here, 3 times 5. Sometimes it is the lowest, sometimes it isn't, but in this case it is. So what if I had to multiply this 3 by to turn it into 15? Remember, it still needs to be an equivalent fraction, so we need to do the same to the bottom, which was times by 5, and we need to do the same to the top, times by 5. So 1 times 5 is 5. Now at this point, it's really important that you understand that a third is identical in size to 5/15. These 2 fractions are identical. I've just made them into an equivalent fraction with the denominator as 15. Now what have I done to this 5 now to turn it into 15? I've times it by 3, haven't I? So I need to do the same to the numerator to ensure that it is still an equivalent fraction. 1 times 3 is 3. And again, 1/5 and 3/15 are identical in size. The size of the fraction hasn't changed at all, the denominator has. Now remember, it was an addition. Now we can begin to add these fractions. So we have the numerators, so 5 and 3 is 8. Now, why would this not be the answer? Why am I not going to be adding these numerators here? 15 and 15 is 30. The reason why this answer is saying that it is 8 parts of 30. Nothing has been split up into 30, has it? These have both been split up into 15, these equivalent fractions here. So remember, when we add and subtract, we don't add or subtract the numerators. The numerators stay the same. Stay as 15. So the answer to this one, the original question, 1/3 add a fifth. We've converted them into equivalent fractions of 5/15, 3/15, and we got to answer of 8/15. So there is our answer. So if we were to have a look at another one, let's do a subtraction now. So let's do 4/6 subtract a third. So 4/6 subtract a third. Now you can see here denominators are different. So when the denominator is different, we need to change the denominators into the same number, so then we can do the calculation, which is a subtraction in this case. So we're looking for a number that is in both the 3 times tables and the 6 times tables. Now remember, you can multiply them together and that will always get you to 1, which if you multiply these two together it gets to 18. However, that's not the lowest number. There's a number that is in both the 3 times tables and the 6 times tables that is smaller than that. In fact, there are 2 that are smaller than 18. Hopefully you've seen that in the 3 times tables, 6 is in the 3 times tables, isn't it, as well? So this 6 can stay exactly the same. If we're trying to get both these denominators to 6, what do I need to do to this 3? I need to times it by 2, so I need to times the numerator by 2 as well. 3 times 2 is 6, 1 times 2 is 2. And now, because the denominators are the same, we can do this subtraction. 4 take away 2 is 2, and then the denominators, remember, stay the same, 2/6. So if you might have seen as well, this can be simplified. We can use that method we talked about in my class, that Connor method of halving till we can't half anymore. If that gets halved to 1, this gets halved to 3. Remembering that these answers are identical to each other. It doesn't matter which one of those you got. Okay, let's have a look at a different one. Okay, let's have a look at 7/8 and 3/4. So I will talk you through this one and you can do one in a moment. So we need to find a denominator that goes into both of these. So we could times these two together, couldn't we, to get to 32. However, there's a smaller number that is in both of these times tables. So 4 and 8. The denominator we can get them to is 8. Now the reason why we want to get it to the lowest common denominator, the lowest number that is in both of these, is that it means that when we simplify it, if we can simplify the answer later on, there are fewer steps for us to do. It makes it easy for us later on. We could multiply these two together to get to 32, and we would still get to the same answer. However, when we come to simplify the answer, we'll have to do more steps in it. So this makes our life easier earlier on, and also the numbers are a little bit easier to handle because they're smaller. So this fraction is going to stay the same, isn't it? Because the denominator is 8. What do I need to do to 4 to turn it into 8? It gets times by 2, which means the numerator needs to be times by 2 as well. 3 times 2 is 6, 4 times 2 is 8. And now we can begin to solve this. So remember that the numerator stays the same, so the denominator stays the same, so we just add the numerator to get to 13. Now this answer by itself is perfectly acceptable. It's a correct answer, 13/8. However, this can be simplified. Now to simplify that, we need to convert this improper fraction. Remember, an improper fraction is when the numerator is larger than the denominator, so it's larger than 1, into a mixed number. And remember how we do that? How many 8s go into 13? 1. And then how many is left over after we've done that? So 9, 10, 11, 12, 13. There are 5 left. And then it's been split up into 8. So 13/8 is identical to 1 and 5/8, okay? So there's an extra step in there just to simplify it. And when you do these questions yourself, you will be asked to simplify them as well. So could you have a go at this one for me? We'll do a subtraction this time. So let's have a go at 5/7 and we'll subtract a third. So remember, you want to get those denominators to the same number and then you can begin to solve this. So if you pause the video there, year 6, have a go at this one and then unpause it and see if you got it right. Okay, so we need to get the denominator to the same number, because if we were to do this at the moment, I've seen some people do things like, right, well, it's 5 take away 1, which is 4, and then 7 take away 3, which is 4. 4 over 4, which is a completely wrong answer. I'll leave that up there just to prove to you how wrong that answer actually is. It's saying really 4 over 4 is saying it's the same as a whole, isn't it? So 7 and 3, we need to get these denominators to the same number, a number that is in the 7 times table and a number that is in the 3 times table. Remember, you can multiply them together, that will always get you to a denominator. Might not be the lowest one, but will always get you to a denominator. If you times them together, in this case, it gets you to 21, which actually is the lowest common denominator. So what have I had to times this 7 by to turn it into 21? I've had to times it by 3, haven't I? So I need to do the same to the numerator, so it stays as an equivalent fraction. 5 times 3 is 15. What have I had to do to this 3? I have to times it by 7, so I've need to times the 1 by 7 as well. 1 times 7 is 7. Remember that it's a subtraction. So now we can solve this. Remember, the denominators will stay the same as 21, and then we need to do 15, take away 7, which is 8. Have a look at this. Can this be simplified anymore? It's a number that that goes into 8 and 21. We can't use that method of halving and halving again because 21 is an odd number. So 8 over 21 is actually in its simplest form. Now can you see this answer here, 4 over 4 or a whole, which was the answer I got if I just subtracted the numerator, subtracted the denominator. Can you see how wildly different those two answers are? How it's absolutely crucial you get the denominators to the same number. If you don't do that with an addition and a subtraction, you'll always get the wrong answer. So it's really, really crucial you do that. Right, let's have a go at a couple more. Let's have a go at an addition this time. Okay, let's have a go at this. Okay, so 8/10 add 4/6. Could you have a go at that one for me, please? Year 6, might have to pause the video there. Okay, so we need to get these denominators to the same number. Now we could multiply 10 and 6 together to get us to 60, but there is actually a lower number that is in both the 6 times tables and the 10 times tables. Here we have a think about the tens: 10, 20, 30. Now I know that 30 is in the 6 times tables, so 30 is the lowest common denominator here. 30 is the lowest number that is in both of these times tables. So what have I had to times this 10 by? I've had to times it by 3, so that means I need to times the numerator by 3 as well. 8 times 3 is 24. 6, I've had to times it by 5, haven't I, to get it to 30, so I need to do the same to the numerator as well. So 4 times 5 is 20, and it's an addition. So now we can solve this. The numerator is going to stay the same as 30, and now we do 24, add 20, which is 44. If you've got 44 over 30, that is perfectly acceptable. That is a correct answer. You might have, if you did get your denominator to 60, you might have got to 88 over 60, possibly, which is a correct answer as well. So let's simplify it though. How many 30s go into 44? Well, 1 does, and how many's left over? There are 14 over 30. This can be simplified further by using that halving method. So the 1 will stay the same. Let's halve 14 to 7. Let's halve 30 to 15. So these 3 answers are all identical to each other. And you can see how it was easier getting the denominator to 30 rather than 60, because you would have had to see that you would have had to work out, you would have had to do this to see how many, and to simplify this, how many 60s go into 68 into 88, it would have been 1, and then you would have had 28 left. It would have been an extra step of simplifying, so that's why it was easy to get to 30. Right, I will give you one more of these year 6 and you can have a go at the worksheet yourself, okay? So let's have a go at 8/9 subtract 5/7. So could you have a go at that one for me, please, year 6? So 8/9 subtract 5/7. So you might want to have pause the video and then unpause it and see if you got it correct. Okay, so we're looking for a number that is in both the 9 times tables and the 7 times tables. When we can multiply them together, that will get you to a guaranteed denominator. Let's have a think. Are there any other numbers that is in both the 9 times tables and the 7 times tables? And there isn't, so we need to multiply them together. So 9 times 7 is 63, so our denominator for this is going to be 63. So what I've had to times 9 by 7, haven't I, to turn it into 63. So I need to do the same to the numerator to get us to 56. I've had to times this 7 by 9 to turn it into 63. So I have to times my numerator by 9 as well to get us to 45. And now we can begin to solve this. Remember that it's a subtraction, not an addition this time. We know that the denominator is going to be 63. So we've got 56 subtract 45. You might be able to do it in your head, but remember, use the methods that you know if you can't do something in your head. Working this out to get to 11. So you've got 11 over 63 now as your answer. Now if you've got this as an answer, that's brilliant. Have a think though, could it be simplified? Now we've got 2 odd numbers, so we definitely can't use the halving method for this. So we need to look and see if there are, is there a common factor? Are there numbers that go into both of these? We know 11 is a prime number, so and that 66, 11 is not in the 63 is not in the 11 times table, so it can't be simplified. So this answer is in its simplest form. So hopefully you got to that one, year 6. So have a go at the worksheet today with these additions and subtractions. Remember to simplify them as far as possible and then to send them back to your teacher. Thanks a lot, year 6.